Armenia's flagship technopark, Enter the Engineering City. Article by Michele Cristani. Published on August 18, 2026 on EVN Report. Shared equipment, shared talent, shared ambition. That's the promise behind Engineering City, Armenia's flagship technopark, where startups, manufacturers, and multinational companies are expected to work not simply alongside one another, but together. The idea is simple. Bring complementary companies together onto the same campus, give them access to advanced laboratories, manufacturing facilities, and shared expertise, and watch products move more quickly from concept to production. Whether that vision is becoming reality is another question. This spring, Integral Solutions announced plans to build a new technology center on the campus. The Armenian company, which develops semiconductor solutions for clients in the automotive, computing, and sensor industries, marked the occasion by placing a symbolic capsule in Engineering City. At the heart of the new facility is a high-performance Siemens supercomputer, enabling Armenian companies to test and validate newly designed microchips locally, rather than sending them abroad. The project is expected to create between 300 to 400 highly skilled jobs. The investment illustrates what Engineering City is trying to achieve. An engineer developing a new sensor for a robotic hand, for example, could walk a few minutes to Integral Solutions to test and validate an integrated circuit. Without that proximity, those highly specialized steps often take place abroad, adding both cost and time to product development. Conceived as campuses where companies establish branches and avoid redundant infrastructure, technoparks bring engineers, scientists, and academics into a shared ecosystem where resident firms pool talent and gain direct access to state-of-the-art facilities at every stage of the industrial process. Today's technology is inherently interdisciplinary. Designing a robotic hand from scratch can require a biomedical engineer to model the biomechanics of human movement, mechatronics graduates to assemble the motors, and a company like Integral to validate pressure sensors that mimic the touch of a human finger, among many other skills. In technoparks such as Engineering City, these professionals can cross-pollinate their knowledge more easily. Located in Yerevan's Nor-Nork district, along Bagravan Street, Engineering City is about a 15-minute drive from the city's universities. The campus is divided into two zones. Engineering City 1, the original site, which houses the Engineering Plaza, a shared manufacturing facility and office space, and Engineering City 2, now under development, which is expected to accommodate 21 high-tech companies, according to Engineering City project manager Marina Minasian. At the heart of the new campus is the High-Tech Accelerator, which supports startups and early-stage companies. Engineering City originated as a public-private partnership between the Armenian government, the Enterprise Incubator Foundation, the leading technology business incubator in Armenia, and the World Bank. Its vision is to revitalize the country's Soviet-era legacy of engineering, manufacturing, and science. Geared toward expanding Armenia's high-tech footprint beyond software, the project established a centralized campus in Yerevan, built around advanced laboratories and industrial production, and it also aims to bring new life to the neighborhood. Its central square has already hosted a big screen for 2026 World Cup games and is intended as a place where locals can relax or walk their dog. Today, Engineering City hosts dozens of high-tech firms specializing in fields like aerospace, microelectronics, and robotics. At full capacity, 30 resident companies will operate there. Some of the 22 companies currently based at Engineering City 1 are expanding to Engineering City 2 by opening a second branch. For now, only the Asnavor supercomputer and Highlink Technologies, which works in cybersecurity and embedded systems, operate at the new campus. However, all companies set to open branches there are expected to do so by the end of 2027, according to Amalia Margarian, Public Relations Manager at the Enterprise Incubator Foundation. At the heart of Engineering City's daily operations is its anchor tenant, National Instruments. The multinational, which will mark its 20th anniversary in Armenia next year, occupies 2 floors and employs 120 people. Its Yerevan branch is a major hub in the EMEA region, running specialized labs that test and validate hardware for automotive and tech giants, such as Mercedes, BMW, ST Microelectronics, and CERN in Geneva. Imagine you're ST Microelectronics and you have a new chip, says Andronik Maliksetian, Principal Solutions Architect and Team Lead at National Instruments. When ST is ready to scale the chip for mass production and sell it for third-party companies' products, They first ship it to National Instruments to make sure it works. The chip is tested in different phases: validation, verification, characterization, and production test, he explains. Configuring complex diagnostic rigs ensures that technologies like 5G antennas and autonomous car sensors function flawlessly before they ever reach a factory floor. The newly announced Integral Solutions Technology Center is preparing to join them, with a focus on local chip validation. Meanwhile, a diverse mix of domestic firms is already active on site. Among them is Even, a homegrown company that designs and manufactures electric vehicle charging stations. It's already being used a lot in the country, Meliksetian says of the charger, which is fully designed and assembled on campus. Nearby, medical technology startup Arm Bionics aims to transcend physical disabilities by developing complete rehabilitation solutions and upper limb prosthetics. These are just a few of the companies that reside in Engineering City with physical branches. Early-stage startups and teams also rely on the infrastructure of the high-tech accelerator building as they scale up. Today, the accelerator hosts fewer than 10 small companies or startups, but the space can accommodate dozens. One of them is ARCS.ai, which runs an educational program to boost the international competitiveness of local students in early cancer detection, aerospace, robotics, and AI. Together, these tenants form a highly specialized hub spanning education, product design, and manufacturing. On the ground floor of Engineering City's main building, the shared manufacturing division hums with daily activity. An automated assembly line for electronic circuit boards and computerized machines for precision manufacturing, so-called 5-axis computer numerical control machines, are available to the engineers working upstairs. This proximity is an immediate extension of their design benches. "I had a project 3 years ago," says Meliksetian. "It was really convenient to come down and see how my order was going because I ordered some parts and imagine it's just under your nose instead of driving somewhere else." When Meliksetian's team designed a custom data acquisition board for monitoring signals, they simply sent the documentation downstairs. The shared facility handled parts procurement, ran the board through automated solder paste stencils and baking ovens, and delivered a finished physical product. So far, one of the most successful examples of mass production for products designed and fabricated entirely within the premises of Engineering City has been Evans' electric vehicle charging stations. This fast, close-knit loop is where Engineering City's shared infrastructure model works best. According to Marina Manasyan, this collaboration is deliberately built into the campus layout, right down to dining habits. "The most important part of the Engineering City is the cafeteria," she says. "When engineers meet at lunchtime, they can work together, discuss ideas, and come up with really interesting projects." One of them is the Physical AI, Robotics, and Smart Manufacturing Research Laboratory, led by Andronika Meliksetian alongside their role at National Instruments. The laboratory operates in the high-tech accelerator. Its members work with Jivan, a humanoid robot used to support automation and robotics projects. Jivan serves as a testing platform for resident companies developing tools like a new robotic hand or a tactile sensor, or androids that could one day handle on-campus logistics, performing pick-and-place tasks and roaming throughout Engineering City. Yet moving beyond circuit boards, casual lunchtime conversations and robots reveals the limits of this collaborative ecosystem. While the hardware workshop is highly active, other shared assets are evolving on a different timeline. The Aznavour supercomputer, donated by the University of Toulouse after it upgraded to a more powerful system, sits quietly in its dedicated center. Subsidized by the government to provide free high-performance computing to local researchers and companies, its integration with the campus's commercial tenants remains, for now, largely aspirational. For industry, there are some difficulties, admits Hirachia Asatrian, director and head of the Center for Scientific Computing at the National Academy of Sciences, who oversees the supercomputer. One of them is trust. Another is security because some companies say, "This is our data and maybe you will do something," he explains, pointing to potential breaches of secrecy. Currently, the machine's primary users are academic researchers and a few niche gaming applications, rather than the engineering firms next door. For those firms, the potential of the Aznavour has yet to be realized. Asatrian says many companies would still rather buy cloud computing services from providers such as Amazon or Microsoft, which run calculations on their servers. By contrast, Adopting high-performance computing, using the Aznavor's processors physically located on campus, is an ongoing, slow cultural process. Meliksetian's physical AI, robotics, and smart manufacturing laboratory also highlights the gap between immediate co-location and deep integration. One of the lab's goals is to automate the campus's manufacturing zone. For now, however, the robot remains strictly a research tool. When asked about active collaborations with incoming residents, lab researcher Grigor Shirinian is careful to manage expectations. Right now, Jivan is not going to be deployed in any factory. We just collaborate. If anyone from the engineering city is open to collaborate, provide some of their techniques to us, we're ready to plug them into our robot and do tests. Currently, the synergy at Engineering City is highly successful as a shared machine shop and prototyping hub. But its grander vision of a fully integrated, automated hardware ecosystem remains a work in progress with an immense potential, not because of negligence or complacency, but because the Technopark is still at an intermediate stage of growth. That ambition rests on a specific financing structure. Since its inception in 2018, Engineering City's official budget has run to $21 million, split evenly between an initial World Bank loan and government-private co-financing. The loan agreement expired on May 31, 2024. Since then, construction has been funded through the state budget via the Ministry of High-Tech Industry. That September, the government approved a further 1.94 billion AMD, about $5 million, mostly to finish the high-tech accelerator. Of that, 1.88 billion AMD went toward construction and furnishing, described at the time as the penultimate planned allocation. The final installment, roughly 1.2 billion AMD, followed in the 2025 state budget, which also set aside about 36 million AMD specifically to cover the Aznavour supercomputer's electricity costs. It's a small figure, but a telling one. The state isn't just building Engineering City, it's still paying to keep the lights on. The leap from a software-heavy reputation to a hardware engineering hub is a deliberate national strategy. As Marina Minassian explains, while software can be written anywhere, hardware engineering depends on a complex shared ecosystem that can turn ideas into exportable products. Bagrat Yenghibarian, director of the Enterprise Incubator Foundation, sees this transition as a major opportunity. In this era of artificial intelligence, this is also the best moment for Armenia to showcase its potential and attract the attention of major global players. Yet scaling this ecosystem beyond its current footprint remains an open challenge. The direction seems right, but to grow further, the model must evolve from low-volume prototyping to true mass production. We are going to build a factory, says Amalia Markarian. Andranik Meliksetian echoes this vision, describing a separate, dedicated manufacturing facility in Engineering City 2, designed to produce quantities in the hundreds of thousands. But physical expansion is only half the battle. The model's human and cultural limits loom large. As Ast Satrian of the Aznavour supercomputer warned, the project's longevity will ultimately be tested by whether it can bridge public infrastructure and private trust. A final caution comes from Yenghibarian. In a field where new technologies emerge all the time, if you are not ready for the new, or if you are not the one creating it, then time will simply pass you by.